my name's Chris. I work for Manulife Financial, an insurance company up in Canada. I usually say down in Canada, but up in Canada. Again, I'm going to talk today about temporal tables and how they're used. So kind of before we get started, I just want to find out who here is using temporal tables today. Excellent. Okay, so look at the agenda. I'm going to talk about what they are, the various types, special registers, how you could use them, creating and using the tables, and also some of the restrictions around them and where temporal tables can really help you. So again, before we do get started, who here is on version 12 right now? Anybody on version 12? 11? Anybody on 10? 9? No? Okay. So again, one of the big things is that DB2 first released temporal tables back in version 10, and they were enhanced in version 11, further enhanced in version 12. So there's been some great new features that were added on along the way. One of the big things to make note of right now is that a lot of the temporal support and additions that they made to temporal tables that were released on version 12 have also been released on version 11. So with the exception of a few new built-in global variables, which I'll identify later on as well, those have not been ported down to version 11, so they're only on version 12. I believe in the base release of M100. So once you're in version 12, then you'll have that new functionality. So again, temporal table is a table that records a period of time when a row is valid. And also, a period is defined as it's a date constraint or a date time frame where a row is valid. So that's kind of how DB2 tracks its period specifications. So you have a valid period of time, and that can be maintained either by the end user or the DBA, depending on what type of table it is, or it can be the DB2 system itself, again, depending on what type of temporal table you have. And every temporal table contains at least 2 date time columns as a period start and a period end to indicate when that row is valid. And again, as I did mention before, is that they have been greatly expanded upon since their initial release of version 10. One of the big things, too, to make note of is that the beginning and ending period values are a inclusive-exclusive relationship by default. In version 12, that's been expanded upon, so now you can override the default of it being an inclusive-exclusive relationship to be an inclusive-inclusive, and that's defined at when you create your period table. So that's a great new feature because when I think of it, I work in the insurance industry. So in insurance, usually we have a year's coverage from usually January 1st to December 31st, whereas in the default inclusive-exclusive relationship, your values would actually be January 1st of 2019 to January 1st of 2020. That would be the way that an inclusive-exclusive works. But the inclusive would be a January 1st to December 31st. So that's what I think of an actual calendar date. So you have 3 types of temporal tables. You have system period table, or system period temporal tables, or STT for short. That's where DB2 maintains the row validity. DB2 maintains the row start and the period end date timestamps. You also have an application period or a business temporal table. That's where you as the end user set up your business rules, and the business rules dictate when a row is valid. And you also have a bitemporal table, which is a table which contains both system period and application period all rolled into one. One of the key things is that a system period table that's a 2-table approach. So you have a base table in your history table. So anytime that you change data in your base table, that gets copied over into your history table, and that's where all of your historical information lives. Whereas an application period, that's where all the data is contained within one table, and you use that business time to dictate when you're going to be looking at data or when that row is valid. So some of the special registers. One thing to make note of is that I did make an update to these slides. I added the second part of special registers. That was updated on the website this morning, although I was having some difficulties on the app. So if you want an updated presentation as well, you can send me an email, which that actually email address has changed because we changed our domain from .com to .ca, but we still get both email addresses for now. So again, or you can talk to me and I can get you the new presentation. Okay, so for special registers, we have 2 new special registers, which are current temporal system time and business time. Both of them are a timestamp. You can also have your business time can be a timestamp or a date. Okay, so for system time, as I did mention, it is a timestamp 12. And if the default is null, and that tells DB2 that it's going to use the current system timestamp whenever it queries your temporal table. And if DB2 will always add in implicitly this statement for system time as of current temporal system time. So that's where if you override this value for the current temporal system time, DB2 will know to pick up this time. And if it's set to null, DB2 knows that it's going to be using current system time instead. You also have the current temporal business time, where I did mention that's either a date or a timestamp. It all depends on how you set up your temporal table. Okay, and the business time, again, it follows the same rules as the system time, where the business time is used for an ATT, for the application table, and the system time is used for the system table. And again, depending on how you have set up your columns or your business, your application temporal table, if it's a date, then DB2 will implicitly cast the current temporal business time as a date. So it does it all for you automatically. There's nothing for you to code. It happens all behind the scenes. There are two additional special registers or built-in global variables. So you have temporal logical transaction time. So this is a timestamp 12 without time zone. It's either a null or a valid timestamp. So this tells DB2 that if it is set to null, it uses the current timestamp as of to set the starting date or the starting timestamp for your temporal transaction. If you override this value, then it's going to use that whenever you insert a row. So it's going to use that timestamp as the period start time. You also have temporal logical transactions, which is a small int. It's either a 0 or a 1. 0 is the default. Then this tells DB2 how many logical transactions are allowed within a single unit of work. So if you set it to a 1, you're allowed to do multiple temporal transactions within one set of work. So once you do a commit, all that work has been committed. Whereas if you set it to a 0, then that allows only one temporal transaction per unit of work. So every time that you execute a temporal transaction, that's one complete unit of work. So next we're going to go on to talk about system period temporal tables. So again, these are tables that are controlled by DB2. So DB2 controls the start and end timestamps. As I mentioned before, that the system period temporal tables uses a two-table approach. So you have your base table, which contains your live or your active data, and you have your history table. So the history table is where if you make any modifications to the data in your base table, that row gets copied over into your history table. So only the valid rows for that current period are in the base table. In order to set it up, you have to have 3 columns. You have to have a row begin, a row end, and a start transaction ID, which are all defined as timestamp 12. Another thing that system period temporal tables can be used for, which is pretty neat, is for just doing simple audit tracking. You can add in a column, which, for instance, if you add in opcode as a char1 generated always as this new data change operation. That's a great way to use to do some basic audit tracking. Just right in your table. So if you do an insert, that value is set to an I. If you do an update, then the value is set to a U. So you know what change operation has happened there. You can also add additional fields to your table too for tracking the current session user. You can have for the last updated timestamps. You can have all that information right on your table, and you can track auditing right there, as opposed to possibly firing off a trigger and putting it onto an audit table. So how to create a STT? Well, as I mentioned before, you have to have the 3 columns that are required is your sys start, sys end, and create timestamp. So as a row begin, row end, and transaction start ID. So this table, I'm just using a simple insurance policy as an example, where you have your policy ID, your benefit coverage, and also these 2, the user ID and opcode, I'm using to track for auditing purposes. So those are generated always as session user and generated always as data change operations. This way I know who has made the changes and also what the last operation was. And the last thing you need, one of the last things you need to do is to specify your period as your system time with your two timestamp columns, the sysstart, sysend. So once you have your base table created, you need to create your history table. So the history table, it's set up identically to the base table. The only difference is you don't specify any of the defaults. They are set up, as you can tell, identically, no differences, just again, no defaults. Because you want DB2 to manage and put that data into the history table for you. The last operation you need to do is you need to link the history table to your base table by doing a simple alter table. Your base table, add versioning, use the history table of your history table. And if you want to, one of the neat things that they've added on as well is on delete, add extra row. So that means that if you delete a row from your base table, without specifying that parameter, that row is just deleted, it doesn't go anywhere. If you specify the on delete, add extra row, a deleted row gets deleted from the base table and gets added to the history table. So this way you don't really lose any data. So you know that at one point in time that row was there. And that's really useful, especially when it comes in terms of auditing or tracking, like fully tracking your data to see, what happened to this row. Oh, it was deleted as of, you could tell the timestamp right there on the table. So I have a bit of an example here, going to walk us through it. So I've inserted, 3 rows into my base table. That's for two different policies, 3 different coverages. And you can see all I specified was just the policy, the coverage, and the coverage amount. So we have a health, long-term disability, and a dental coverage. So there are the 3 columns here that I've inserted, and we have our opcode, which is the data change operation. So they're all I's, so these are all inserted. The user ID, which is my ID when executed it, and you have the next 2 columns, which are DB2 managed. So this is DB2 managing the start and end times. So you can see when this row was inserted. So it was inserted at 9 a.m. On January 1st, and your sysend is high date. So that means that this row is valid until, in essence, the end of time. Next, I'm going to update a row. So I want to change my coverage for my health benefit to be $9,000 for this policy. So I issue that update. And if you notice here, where we have the A111 for health, the coverage is now $9,000. The opcode is a U. Okay, so that indicates that it's been updated, and also by whom. And we have our sysstart is now on March 18th at noon is when it happened. And again, the sysend, this hasn't changed because this row is still my valid row. From that change period to the end of time, this row is valid until I delete the row. Next, I want to see what happened in my history table. So like what actually got copied there. And all it is, it's a copy of your existing data that used to be there in your base table, with the exception of the sysend. So if you notice the sysend timestamp, so it's 12:33 p.m., and you have the microseconds there. These 2 line up perfectly. So that's how you have that continuous flow. So this records on my history table was valid from January 1st at 9 a.m. through to 12 p.m. and 33 seconds. At 33 seconds, it's now this row. So that's how you have the continuation of time as time goes on. And the more updates you make, the more rows get inserted, the end time stamps change, and that's how you kind of track the history of things as it goes along. I'm going to update again for the health coverage. I'm going to set my coverage equal to 0. So again, I have my updated row. Coverage set to 0. This is now done on May 1st at 4 p.m. Again, we have these 2 timestamps lining up again to what we have. The row which used to be updated for the 9,000. Yeah, go ahead. This is high timestamp. I don't know why it's not 1231. It really should be 1231, but this is because whenever we've coded high date, we've always done 9999 1231. For some reason, they did 1230 at midnight. So you're missing a day, really. But yeah, then this is what DB2 specifies, and you can't change it. Yeah, so I've tried to do updates. I tried to specify it, and it wouldn't let me because it's a DB2 managed column. because it's generated always by DB2. So yeah, so I kind of had a gripe with that as well, that it should be 1231 and then 1159.59. Yeah, or 2359 rather. Yeah, I agree. Yep, that just seems kind of odd. Pardon me? Yeah, exactly. We'll be on DB213 by then. Well, yeah, we'll see how things go. So again, we have our history table. We now have both rows. And again, there's no data modification being done to the rows. The only modification that's happening is on the sys end. And these are the columns that DB2 is managing. So he's just updating this end timestamp to the start timestamp here. So that this is how, it has a continuation. And we have that continuation here between these two rows. I truncated off the last byte just to make it all fit a little bit nicer. But you have those two lining up perfectly again. Again, how to time travel, besides going 88 miles an hour in a DeLorean. So there are 5 basic ways to kind of navigate through your system period temporal table. Okay, you can do a basic select star from your table, and DB2 will it will implicitly set the current the system time as a current timestamp. You could also set the system time as of a timestamp, and put a date in there, so it will set the timestamp for that period for the period specification. So and get it as of this point in time. The next option is setting, getting your your system time between two, so from timestamp to timestamp, and this uses the inclusive-exclusive method. The next option you have is, for your system time between two values, where it uses the inclusive-inclusive. And the last one, this here. So this is where you're setting, which is what most people will traditionally do in your queries or in your applications. You'll set your current temporal system time as of a timestamp, and then do your select. This is what I've marked in yellow here. This is implicitly added into your query for you, so you don't need to specify this here. If you're setting it, you don't need to specify it in your query, because DB2 will implicitly pick it up from that global variable. Again, so for this example, so I said, what are the values as of April 1st at midnight? And at April 1st, because I made my change, you can see here on May 1st. So this is what the tables had as of April 1st at midnight. So it looks to see what rows are valid as of that period of time. Had I specified the between, if I would have done from April 1st to May 2nd, that's when I would have picked up multiple rows for that health coverage that was changed. And again, and you can always follow through to see what were the valid periods, and you can see that April 1st is right in the middle of here, so all these rows are valid. And what DB2 also does implicitly behind the scenes of this as well is that it actually transforms that query into a union all between your base table and your history table for you. So that's how DB2, and it does the same thing even with archive transparency. So it's using the same technology where it does that union all for you behind the scenes, and it knows that if you're searching as of a particular point in time, it will do that union all for you, and it's all hidden. You can see it in your explain if you take a look at there, but you actually don't see that in your query. So when you run it, you just run it like this, and DB2 will find the proper answers for you. So now that we have it on, we have our the STT going over to the history table. How do you turn it off? Well, it's simple. It's just, you drop your versioning. So you alter your table, your base table, drop versioning. It's immediate. No need for a reorg. There's no advisory flags, no restrictor flags. You can turn it on and off at your leisure, at your heart's content. So if you want it on for a couple hours and you want to turn it off, you can do that. The only thing you cannot specify this alter without any other alter statements. And also, versioning cannot be dropped if there are any views, MQTs, or any SQL table functions that depend on the system time period. Now, the documentation says that it may invalidate your packages. They should really change that word may to it will invalidate your packages. In a simple example where I just did a select from my base table, and that was my COBOL program, I dropped versioning, and it invalidated the packages. So for a simple query, it still invalidated the package. So it just said you can either do a manual rebind or just let it auto rebind. So just be forewarned that it may invalidate your packages. I haven't seen an example yet where it doesn't invalidate the package, but it may. So some of the restrictions around using a system period temporal table. The system period table and the history table spaces must be recovered as a set if you're doing a point-in-time recovery. Now you can recover them individually as long as you specify the verify set no option. And I guess the main reason why you normally recover them as a set is because the history table contains all the historical information from your base table. So you want those two to kind of be in sync. So you don't want additional information or older information in your base table that you have in your history table that has already been added there, because as soon as you modify a row in your base table, you can now get a -803 because of the unique constraints there. Also, you cannot alter the schema of a system period temporal table or the history table. The only caveat that the only thing you can do, you can add a column to your base table, and DB2 implicitly adds that column to your history table without you having to do anything. So you can add columns to your base table, and then those columns get added to the history table for you. You cannot drop columns, you can't modify, you can't change length from a char 10 to a char 20. To do that, you'd have to drop the versioning, make the changes on both tables, and then add the versioning again. So it's a three alter approach. It is possible, it is doable. It's just something to keep in mind that once you have your versioning set up, you have to keep them in sync, and if you do make a change, you have to drop the versioning and make those changes. Oh, and also, one of the good things that your history or your base table can't be dropped while your versioning is turned on. So you cannot drop, I believe that you can drop them as a set, but you cannot, no, sorry, you can't even drop them as a set. It will not allow you. In my query, yep.
Yeah, is there a way to manually manipulate the generated data? You decide you want to change it?
No. No, I've tried. It will not let you because it's a generated. You can in your history table. I don't know what that does because those are not generated. Those are just basic columns. Yeah, so you can in your history table, but not in your base table. In your base table, because they are generated always, DB2 won't let you modify them. So again, I don't know what would happen though with the queries, how it would work if you were to modify the timestamps and your start and end timestamps in your history table. How DB2 would return rows back is something that would be an interesting thing. But yeah, you'd have to know your data really well to do that though, because again, like these are maintained by DB2, so DB2 maintains those start and end timestamps. It's in once you get into the application temporal tables, which we're going to talk about next. That's where we as a DBA or as a developer or the business, they have control of the validity of that period, and then that's where we can kind of walk through an example of how rows work and actually modifying those dates as well.
You could turn versioning off, I guess, and then delete some rows, and then turn it back on.
But even still, even for modifying the start and end timestamp for the base table, the default is generated always.
Yeah.
So that's why you can't modify them, as far as I know, even with versioning off, because they are generated always columns.
Yeah.
Because they're not the typical with default with the default timestamp. It's a generated, so it's a system generated column.
But I guess mine was more of a follow-up question: is if you had data that was put on there that said, "Oh, I didn't really put that data on there." If you want to take it off, but you don't want it on the history.
Oh, okay. You can, yeah. So you can turn version. Yeah. So that's right. Yeah. That's right. So I guess the question is, if you have data that you don't want to be archived, it was added there in error, how do you get that off without it going to the history table? And that'd be to say drop versioning and then delete the data. Or you can do another approach of delete the data, let it go to the history table, and then delete it from the history table. Because you can still perform all operations on the history table. You can select directly from the history table. You don't have to go through the base to go to the history. You can go directly to the history. Yeah. So if like a point-in-time recovery, you mean? Yeah. So point-in-time recovery, you need to do both table spaces as a set. Otherwise, the only way to get around that is if you recover with a verified set no. So that's how you would recover them individually. But again, you should kind of keep them both in sync because that's how you have your data is saved that way. And that's why it's one of the things that you should know your data really well, what you're restoring to. Just like any point in time recovery, we should know what we're restoring to. Same thing with just like rebuilding an index or recovering an index. Yeah. So next up we have application period temporal tables. So again, these are controlled by the user for when the row is valid. There is no history table, so it's a much simpler approach in that all your data is in one spot. You only need a row begin and a row end, which can be timestamp 6 or a date. So it can be either or. So how do we create them? Again, same type of policy. Going to do insurance application. This is where it will be a bit more viable. So where we have our ATT with our policy benefit coverage, and when all we have is a business start, business end, and they are date columns, and the period is the business time of the business start, business end, and this is where we have that inclusive keyword. Because I want this to be inclusive, inclusive. If I didn't specify inclusive on that business end, it would have been a default of inclusive, exclusive. And also, you want to add a unique index to it. Okay, so you have create unique index name on the ATT with the business keys, followed by your business time without overlaps. So you have two options there. You can have a with overlaps and without overlaps. So that just means for your business time, can I have overlapping business time for this business key? So for a policy and benefit, can I have the same time frame? Let's say January 1st to December 31st. Is that a valid business case? For a unique index, it cannot be. You could only have a without overlaps for a unique. For a non-unique index, that's where you can specify with overlaps. A good example would be if you have an employee, that employee can be in multiple departments in the same time frame. So you can have somebody that's in HR and in IT in the same year or the same month, and that may be a valid business case. Whereas that IT department that has to be a unique rule where that business can only be within one time frame. Okay, so again, one thing to make note of is that if you're specifying without overlaps, or if you're specifying a unique index, it has to be without overlaps, and non-unique can be with or without overlaps. But traditionally, you have non-unique with overlaps. So I'm going to add rows to my table. So again, so I have my policy, coverage, amount, and then here I'm actually specifying the values because they're no longer generated always. So I have to specify the valid periods in time of when this row is valid. So this health coverage of $100 is valid from January 1st to December 31st. Whereas before, DB2 managed that start and end time. This is where I'm managing it here. So any time between these two dates, that's when that amount for that policy is valid. This is updating the old way. So before, if you're not using temporal tables, how would you traditionally achieve this? You'd have to update your table. You have to specify. So set your business end to 0430 for this policy and this benefit. So that's one statement. Next, you want to insert into the table these values. So what I'm doing for the month of May through July, to the end of July. I'm increasing their coverage to $500. Let's say you went away on vacation, you want a bit higher coverage while you're gone. When you come back, you're going to down your coverage again. So for that 2-month period, you want more coverage while you're out of country. So again, you have to change the end date for the initial row, insert your new value of $500 for that valid period of time, and then I'm going to insert again a new row to cover off the last from August 1st through to the end of the year. So that's how I used to split a row into multiple segments. Doing the exact same thing using temporal tables, one statement. I'm updating my ATT for a portion of business time between these two dates, set my coverage to $500. Simple. Makes life so much easier, so much less complex. So DB2 manages the splitting. DB2 manages because it knows that the initial row went to December 31st. So there must be continuation because I'm not deleting that data. So it knows that it's just going to split the January 1st to December 31st, put this row in here for $500 for those 2 months, and then make the continuation on. So I think it's pretty neat, just how DB2 did that and how they did that there. You can do the same thing with the delete. So if you want to delete data, so you want to delete data from your ATT from April 1st to August 30th. So again, what happens here is that DB2 deletes that data in between. It knows that the day prior to that is March 31st, so it sets that end date. So as opposed to you actually modifying that end date to March 31st, setting the start date, deleting the row, setting the start date of that next row to September 9th, it does it all in one query. Okay, behind the scenes, DB2 is doing all those statements for you. So he's still issuing, those deletes, those updates. But all that you're doing is, as a DBA or as a developer, is issuing that query.
I'm guessing the business end date can be 99.99.
Yep, you can set it to whatever you want. Yep. You can set even like the business start, you can set it to load date, so 0001, 0101. Yep. So data retrieval is very similar. Actually, it's identical between an STT and an ATT. So and again, the business time, it's implicitly set as the current date or the current timestamp, depending on how you define your column. If you defined it as the business start and end, if you define them as timestamps, then it'll be a timestamp. If it's a date, it'll cast that current timestamp to date. So it does it all for you. Again, setting it as of a particular date that it picks just for that particular date, or the from and to is the inclusive exclusives, and between is the inclusive. Data manipulation, as I've identified before, this is kind of just simplifying it, so you can do a delete from for portion of business time, from value to value. And the same thing for an update. You do an update with your statements for portion of business time, and then from and to values. That's how you modify and update data. Just like setting it here, setting it for that portion of business time. And I want to set it to I want to set the coverage to 0 for this policy and this coverage. Another thing is that they've introduced RI for temporal tables for application period temporal tables. So compared to traditional RI, temporal RI is much stronger because you can have RI for your parent table, and you can have RI for your child to parent table that has the with and without overlaps. So there's a lot more that you can do there. There's a lot more checking you can do, and it reinforces the rules that you have to have a parent for a contiguous time frame, which are kind of like outlined. Could give some examples as well. Because for every row in a child table, you must have one or more corresponding rows in a parent table, and they must exist with a matching key. And also the parent rows must completely cover off the child when that child row is valid as well. So you can't have a parent that ends before its child, whereas in a regular DB2 table, so long as a parent row exists, you can have child rows. Whereas now, if you're using application logic in the business time, if your parent row exists, let's say for January 1st to January 31st, you cannot have a child row that goes from January 1st to February 1st, because that's not valid. It's only valid to when the parent is valid as well. So that's why you have to have contiguous parent rows to make those rows valid. So here, this kind of example that I pulled off as well is that we have your typical department and your employee. So I've set up the department as the parent. So he has the business time of department start, department end, and the primary key is the department number and the business time without overlaps. I've created a unique index, so it must be without overlaps. So that means I can only have a particular department number for that period of time. I can only have between that date, start date and end date. That's when I can have that department. And I have my employee table, who has the business time as employee start, employee end, and a foreign key going back to the department number and the business time. And he references department number and business time. On the child table, I'm just creating a regular index, so duplicates are allowed, and that index is with overlaps. So that means that I can have an employee, I can have an employee under the same time frame in multiple departments, and that's okay. Okay, but you cannot have the same employee in the same department on the same. The same employee, same department in the same time frame. That's the unique violation. Kind of visual representation. So you can have, so long as your child row exists within the duration of your parent row, then it's valid. So you can have it being the entire. So up at the top we have the child row for the entire duration of the parent row, or just a portion of the parent row. You can have multiple children, multiple different children during that parent row's validity, or partway through, or just up until the end. Some things that we can't have, you cannot have a child row, because this guy started before that parent row began. That's not a valid row, because that breaks the business rules of the temporal RI. Because although this might be the HR department, so you have the HR department, still HR department, just year to year. Let's say they took a break, we didn't have HR for a few months. Okay, they kind of shut down shop and they all went on vacation. But yet we still tried to add individuals to that department. Well, that's not valid because that department didn't exist then during that time frame. So it's not like your traditional RI where it checks to see, does that row exist now? Not to say, whereas temporal RI, it's, did it exist at this point in time? So that's how that temporal RI is stronger than traditional RI. And so all these ones from 1 through 6, they're all completely valid. So you have children, so long as they're during the same contiguous parent row, they're valid. And so long as they're within a valid range, they're okay. But it's when they, he started and he was okay because he was during that time frame when that parent row was valid. But partway through, that parent row became invalid during that time frame, so this row would not be allowed to be inserted. He would actually have to be broken up, end here, continue from here to the end. That's how you would have a valid child row. It's kind of like what's happening here. So you had him valid at the beginning, stop partway through, continued along. So really, where temporal tables can really help you. The biggest thing that I can think of is working in insurance policies. I worked on the admin systems for, well, I guess now it's been almost 13 years. They'd be so much beneficial if they would start using temporal tables there, but unfortunately they're still on VSAM. Hopefully that we can get them into DB2, and we can use these temporal tables because it does what all their application logic is currently doing. It's splitting up those rows. So it's, you have that valid period for the year. It's like, we're modifying their coverage as of a particular date. We want the coverage to go on to the end of the year. Well, it's just one update statement. You don't have to go through a major COBOL program and make all these changes. It's really simple to update that information there. Same thing with, going through your annual maximums in insurance. You want to see, am I close to my annual maximum? So that could be like a cumulative throughout the year, so kind of like a year-to-date summarization too. Even with verifying claims. So if you want to verify your claims on insurance policy, you can kind of go through and you can say, how much did I spend as of March 1st? How much did I spend as of a particular date? So you can use those to kind of think about, how can I use these temporal tables, especially on the business side of things, to kind of, leverage this functionality. A good example I saw online as well was for vehicle rentals. You can track things like who has it and when, who had the vehicle, what type of insurance that was purchased on it, what was the mileage in, mileage out for that time frame, the maintenance schedule, when was it last maintained, when were the tires last changed. So you can track all that information all within an application period table. And you can query as of a point in time, or to say, from January till April, who had it, how many miles did it go. So you could pull that information very easily right out of DB2. And also for a system period temporal table. So for those that are not in DB2 12 yet, one of the big things is that DB2 catalog tables, especially for all the RTS tables, they all come shipped with history tables ready to be enabled for versioning. So you can add that versioning right away out of the box, and you can start tracking using the system period temporal tables. The only thing to make note of is that you should really have a very good purge process set in place for your STTs, for your RTS tables. Because if you don't, by default, those are being updated every half an hour. So if you think for every single table that's in there, you're going to be updating a row every half an hour, how quickly that can add to your history table. So you're going to have every half an hour, let's say if you just have 10 table spaces with 10 partitions each, you're going to have 100 updates to those tables that's going to be added to your history table every 30 minutes. And that's just a small example. So that's why IBM strongly recommends that if you're going to enable this, have a very good purge process set in place. So this way you can clean those up, let's say be it monthly, be it quarterly. But one of the great things with those DB2 catalog tables, which I'm in the process of getting them turned on in a non-prod environment, is you can look at history usage throughout time. How do the tables look a year ago? How do they look 6 months ago? How do they look 2 years ago? How is the usage over time happening? You know, are we growing steadily? Are we decreasing in volume? What do those RTS looks like? You know, do we need to reorg more frequently because we see those spikes happening at a particular point in time? So that's when we can do our analytics on the on those system tables, right in the history, and you know, we have all that information as opposed to just pulling out and say, oh, these look kind of high, or just manually tracking it down on a monthly basis. You can use the temporal tables, and it does it for you. You just have to have the analytics behind the scene to pull it into something that's a graphical view, or you can pull that information right out of the DB2. So that's a great thing to make note of for the STTs, is that they come by default in version 12. You just have to add you just have to enable the versioning. So again, and that's for all the history tables. I've added them in the notes of the presentation as well. So I think there's 13 or so for the RTS tables. So you have stuff from systable space stats to audit policies, context, DB auth, pack auth, plan auth. So you have all those tables that are storing all that could be storing your historical information. So if you want to see, you know, how did my DB auth change over time, if you have versioning enabled, you can look into your history table and find all that information for you. Or you can look at a particular point in time who had access to this data. Some references to where we got all this information from. So again, IDUG, always a great source. Same with the IBM Knowledge Center, if you can kind of navigate your way through it. Although I know it has changed quite a fair bit in the past couple of years, but still a bit of a challenge to try and find some information. That's why, you know, IDUG is always great, so is Google. Google is always your friend. And again, there's my email. If you need to get a hold of me, please, by all means. So I want to thank you guys. If there are any questions. Yep.
Have you played with triggers with temporal?
No, I have. So the question is if we've played with triggers with temporal tables, and no, I haven't yet. So, and that may be one of the things I'll be looking for in an STT. Once I get that enabled in our non-prod environment, in our sandbox, to start seeing, you know, what are all the possibilities of what we can do and how we can better pull those analytics out. Any other questions? Yes.
How does unloading and loading work, like between separate environments?
So unloading and loading between environments. So I guess between, let's say, prod to non-prod. Okay. I haven't done it. I did it for. Yeah, so for temporal tables, I have not tried it. I've done it for application transparency. Transparent archiving, for transparent archiving, which was released at the same time as temporal tables because they use the same technology behind the scenes. So I assume it would be the same, where you would have to do an unload from both your base and your history table. Whereas if it's an application period table, that's just one table, so you just do an unload and load. And since you are since you're using the DB2 utility, it should take those default values that you're specifying, so it wouldn't overwrite those. Anything else? Thank you very much, guys. Appreciate it. Enjoy the rest of the conference. Thank you.